Yeah, hello, dear students. In the previous videos, I have uploaded inverse trigonometry functions, matrices, determinants. Now I am doing continuity and differentiability. In this, I have done already 5 marks questions I have uploaded. Now I am going to explain the 4 marks questions. Around 10 to around 10 problems, around 10 to 11 problems, I am going to explain. Definitely, you can answer one question 4 marks from those questions. Maximum chances are there. Maximum chances are there. You can improve your score. Now, you can see find the value of t if f of x is k cos x by pi minus 2x when x not equal to pi by 2. 3 when x is equal to pi by 2 is continuous and x equal to pi by 2. Given the function is continuous and x equal to pi by 2. Since f of x is continuous, I can write since f of x is continuous at x equal to pi by 2. So the function is continuous at x equal to pi by 2. I can write limit x tends to pi by 2. F of x is equal to f of, so because no, at x equal to pi by 2, right? F of pi by 2 I can write. Correct? Now I can write limit x tends to pi by 2. What is f of x when x not equal to pi by 2? K cos x pi minus 2x. When f of pi by 2, the value will be 3. Right? Now it's a very simple problem. I can take it k into limit x tends to pi by 2. Here I can take this one, cos x means sin 90 minus x. Sin 90 minus x is cos x. You take here 2 common. If I take 2 common, this will become 2 into pi by 2 minus x, which is equal to 3. Right? Simple thing. Cos x sin 90 minus x by 2. You take common pi by 2 minus x. Right? Pi by 2 minus x. Now, just I have taken 2 common, right? This will be pi by 2 minus x. Now, this 2 you can write here. I can write k by 2 into this one. You can see sin theta by theta, right? It will be 1. I can write if you want limit x tends to pi by 2 sin pi by 2 minus x pi by 2 minus x, which is equal to 3. But we know this value. We can check this value. This value is 1 sin theta by theta. So k by 2 into 1 is equal to 3. 2 cross multiplication. K equal to 2 into 3, 6. So our answer is k equal to 6. Here this is k by 2 into this one. This value is 1, right? You don't confuse. This is total. I have taken this one. This is into this one. This has 1. K by 2 into 1. 3. K is equal to 6. I will explain important problem. Take the function is you take this is the function. It is continuous at pi by 2. Limit x tends to pi by 2, f of x equal to f of pi by 2. Limit x approaches to pi by 2, write f of x. At pi by 2 the function is 3. Here you take 2 common, k you take it out. Then you get limit x tends to pi by 2, sin of pi by 2 minus 6 by 2 into pi by 2 minus 6, k by 2. If you want, you can say one more step. Without writing this step, then you can write this step. You can write that k by 2 into 1 equal to 3, k equal to 6. I will explain the next problem. Now see this problem. This is now I am doing second problem now. See here, the function f of x, kx plus 1x less than or equal to 5. 3x minus 1 x greater than 5 is continuous at x equal to 5. You observe here, they are splitting the function at 5. At 5 or less than 5, kx plus 1. At more than 5, the function is 3x minus 5. Even equal to the same thing. Correct. It's left of 5 or equal this one. Right of 5, this is a function, right? Now in that case, what can I do this one? I observe here. how to solve this problem. When they are splitting into a particular number, then you should think left limit and right limit. That is left limit and right limit. I can find now. Since f is continuous, since f of x is continuous at x equal to 5, the function is continuous at x equal to 5, you can write limit x tends to 5. F of x is equal to f of 5, right? They are talking at 5. 5, they are given it is continuous. When it is continuous, this it holds, right? Now, since limit exists, from this I can conclude limit, whenever limit exists, limit x tends to 5 minus f of x is equal to limit x tends to 5 plus f of x. Because left limit should be equal to right limit where limit exists. Then I can write limit x tends to 5 minus left of 5 kx plus 1, which is equal to limit x tends to 5 plus more than 5, 3x minus 5. I can write 3x minus 5, right? Now, you can substitute the limit directly. K into 5 plus 1, 3 into 5 minus 5, you will get 5k plus 1 equal to 15 minus 5, you will get 10. 5k is equal to 9. K is equal to 9 by 5. That is the required answer, right? Since it is continuous, limit x tends to f of x equal to f of 5. But because they are separating the function at 5, left of 5, right of 5, in that case, think left limit, right limit. Since limit exists, left limit is equal to right limit, then you simplify a is equal to 9 by 5. Now see this function again. In this problem, they separated the function at x equal to pi, left of pi, right of pi. So you can think, when they are talking about this one, so this is pi, right? So right of pi is cos x, left or equal to pi is kx plus 1. Correct? This you remember. Whenever they are discussing like this, you should think left limit and right limit. Now I can write, since f of x is continuous, f of x is continuous at everywhere, but they are separating here, consider pi. At limit x is equal to pi, it is continuous at x equal to pi. Now I can write limit x tends to pi, f of x is equal to f of pi. Now since limit exists, left limit is equal to right limit. Limit x tends to pi, f of x tends pi minus f of x equal to limit x tends to pi plus f of x, both equal to f of pi only. Now you can see here limit x tends to pi minus left of pi means kx plus 1, limit x tends to pi plus, when they are talking pi plus cos x. Correct? Now you can substitute the limit directly. This is notation. This is not minus pi, pi minus pi plus notation. You can substitute k into pi plus 1 cos 180, right? This is k pi plus 1 cos 180 minus 1. Correct? You will get this one, transfer that side. K pi is equal to minus 2. K is equal to minus 2 by pi. That will be required answer. Like previous one, and similar to the previous one, I will do next problem. Now see in this problem, again the same function is given. Left of 2 kx square are equal to 2 kx square, right of 2 3 is given. You can think when I give like this, just give right. So it is 2. Right of 2 the function is 3. Left of 2 the function is kx square. So definitely should think about left limit and right limit. Since f is continuous, f is continuous is x equal to 2. and this is continuous at x equal to 2, I can write implies limit 2 means 2, let me limit extends to 2, f of x is equal to f of 2, like this. Limit extends to 2 means extends to 2, f of x equal to f of 2. See, the limit is continuous. From this I can write limit. So whenever limit exists, limit extends to 2 minus f of x is equal to limit extends to 2 plus f of x. Left limit is equal to right limit. Then I can write this implies limit extends to 2 minus left of 2 kx square. Limit extends to 2 plus 3. Right? Now you can check. Apply the limit. K into 2 square. This is 3, right? So you will get 4k is equal to 3. K is equal to 3 by 4. That's it. That is the required one. I will explain the next problem. See, in this problem, they are asked to find the relationship between a and b, so that the function f of ax plus 1 when x greater than less than or equal to 3, when x greater than 3, bx plus 3. Again, they are splitting the function, right? You observe here at the 3, right of 3, bx plus 3, left of 3, ax plus 1. So definitely you should use left limit, right limit. I can write, since f is continuous, f is continuous at x equal to 3, I can write limit extends to 3, f of x equal to f of, then when it is continuous. Since it is continuous, I can give right. I can give, since it is continuous, so the function is continuous, the given it is continuous, I can write limit extends to 3 f of x equal to f of 3. Now, from this I can write limit extends to 3 minus, since limit exists, left limit equal to right limit. These two are equal. Then I can write limit extends to 3 minus left of 3, ax plus 1. Limit extends to 3 plus right of 3, bx plus 3. Right? Substitute the limit in this. I can substitute limit a into 3. Don't substitute minus 3. This is notation. Left of 3, right of 3. Plus 1. b into 3 plus 3. 3a plus 1. Which is equal to 3b plus 3. I can write 3a is equal to 3b minus 2. I can write, because I have written ax plus 1 left of 3. 3a plus 1. This is bx plus 3. 3b, I guess the function is given ax plus 1 and bx plus 3. Correct, we will get this one. I can write this one 3b plus 3. I can cross this one 3b plus 2. If I divide this, a is equal to b plus 2 by 3, or a minus b is equal to 2 by 3. This would divide with 3, or again a minus b is 2 by 3, or a equal to b plus 2 by 3. So that is the relation between a and b. Now see, in this problem, there are some find the values of a and b such that the given function is a continuous function. But you can observe here, in the function, they have separated the function into 2 points, left of 2 and at 10 also. Check that left of 2 are equal to 2, 5. Right of 2, ax plus b. Same thing, left of 10, ax plus b, right? Left of 10, ax plus b, right? Right of 10, 21. So here they have separated the function into 2 points, 2 and 10. That means, but they have given it as a continuous function. So you can take, since f is continuous at 2. Firstly, since f is continuous at x equal to 2, limit x tends to 2, f of x is equal to f of 2. Since it is continuous, now you can write limit x tends to 2 minus f of x equal to limit x tends to 2 plus f of x, right? Limit x tends to 2 minus left of 2 is 5. Limit x tends to 2 plus function f of ax plus b. Substitute the limit 5 is equal to a into 2, 2a plus b, equation 1. How I got this? A into 2, 2a plus b, equation 1. I can consider here. Again, the function they're talking at 10, left of 10, right of 10. F is continuous. F is continuous at x equal to 10. So limit when it is continuous and x equal to 10, limit x tends to 10 minus, again 10, f of x is equal to f of 10. Again, since they separated the function at 10, again limit this means left limit is equal to right limit. Left limit is equal to right limit. Now if I take this one, limit x tends to 10 minus left of 10 ax plus b. 10 plus 21. This is notation 10 plus. Correct. That is the only notation. I can substitute the limit here. You can observe in this problem. Just if I substitute the limit, the value what it comes, you can check that. Substitute the limit. You will get 10 a into 10, 10a plus b is equal to 21. I can consider this one, right? So I can substitute the value here. So after writing this, you can also check the value of this one. Correct? You got like this, right? What I will do now, just you remember this point here. You should find the values of a and b. After finding this, I can write here limit x tends to 10 minus ax plus b. Again 10a plus b. We substitute limit which is equal to 21. This equation 2, I have equation 1. 2a plus b is equal to 5, equation 1. Solving these two. If I solve these two equations, this I can subtract this. B I can eliminate, right? Plus b minus b, right? I can eliminate this. Correct. Now 10a minus 2a, 8a. 16. 8a is equal to 16. A is equal to 2, right? But you can take any one of the equation. 2a plus b is equal to 5 from 1. This is 5. But a value 2. 4 plus b is equal to 5. B is equal to 5 minus 4, 1. A is equal to 2, B is equal to 1. So that is the required answer, right? Since it's continuous set 2, we get one equation. Continuous set 10, we get one more equation. Solve those two equations, then we get A is equal to 2, B is equal to 1. I will explain the next problem now. See, this is one more problem, 7th problem. For what value of lambda is the function defined by f of x lambda into x square minus 2x, x less than or equal to 0, 4x plus 1, x greater than 0 is continuous at x equal to 0. Check that here, this is the problem, right? They are asking for what value of lambda is continuous. Since it is continuous, I can find here See, they are splitting the function left of 0, right of 0. Always think about that. 0. Right of 0 means 4x plus 1. Left of 0 means lambda into x square minus 2x. Like this is the function, right? You can just observe here. Left of 0. Now, since f is continuous, and x equal to 0, limit x tends to 0, f of x equal to f of 0, because they are talking continuous and x equal to 0. Now we can write, since limit exists, left limit equal to right limit, x tends to 0 minus f of x equal to limit x tends to 0 plus f of x, which is equal to f of 0. But here left limit equal to right limit. I can write limit x tends to 0 minus left of 0 lambda into x square minus 2x equal to limit x tends to 0 plus 4x plus 1, right? You get 4x plus 1. I written the function right. If I substitute this one, lambda into 0 you will get here. This is here. See, if I substitute the limit lambda into 0 minus 0, this one 4 into 0 plus 1, then you will get lambda into 0, 0 equal to 1. For any value of lambda, the function is, see, for no value of lambda, the function is continuous. For no value of lambda, f is continuous and x equal to 0. We don't bother with the lambda, but we are getting 0 equal to 1. It is a contradiction. For no value of lambda, f is continuous and x equal to 0. For no value of lambda, f is continuous at x equal to 0, right? Then we will solve the next problem now. Right. So finally we get 0 equal to impossible case. For no value of lambda, f is continuous at x equal to 0. Then I will explain the next problem. You see this problem, they are asking find all the points of discontinuity of the function of the greatest integer function defined by f of x equals to step x. F of x equals to step x. You should find all the points of discontinuity of this function. We have case 1. So when we are talking about case 1 here, think about case 1. Suppose the given x is a real number but not an integer. Okay, let's see be a real number. You can consider let's see be a real number which is not equal to, think, is a real number which is not equal to any integer. Which is not equal to any integer. Let C be a real number which is not equal to any integer. Then if you take like this, now definitely I can define the function. Limit x tends to c f of x. Limit x tends to c f of x means step x right. Since it's a real number but not integer, you will be step of c, it will come. Function value. So I can also write f of c, because given f of is step x, f of c equals step of c. Therefore I can write limit x tends to c f of x equal to f of c. Therefore I can say here f is continuous. Correct, the function is continuous at all, you can see, at all real numbers except integers. Your f is continuous at all real numbers not equal to integers. F is continuous. F is continuous at all real numbers. You can write continuous at all real numbers, not equal to integers. At all real numbers not equal to integers. not equal to integers. Correct, not equal to integer, not equal to integers. Not equal to integers. Right, this one. You can come to case 2. Case 2 means suppose consider, let C be an integer. Let C be an integer. That means here C is not an integer. Like that because instead of writing this much, let C is not integer, C is an integer, let C be an integer. If we take integer here, then you can think, you can find limit x tends to C minus f of x. Limit x tends to C minus f of x means stop x, right? Left of C. Left of C means this value will come C minus 1. It will come C minus 1. Now if it will come C minus 1. If we take limit x tends to C plus right limit f of x, limit x tends to C plus step x. So C plus it will come C, right? C plus means more than C, it will come C only. Step function, correct. Left of means C minus 1, C plus, because it gives integer part at C plus 2 point something. Step of 2 point something will be 2. Correct. Step of 1.9 something it will be 1, like that you will get. Integer part you will get. But both are not equal here. Limit x tends to C minus f of x not equal to limit x tends to C plus f of x. Both are not equal. So here, since limit doesn't exist, so function is not continuous. Correct, you can write function is not continuous, the function is discontinuous at every integral point. Limit only doesn't exist, right? I can write limit doesn't exist, therefore the function is discontinuous at all integral points. So limit x tends to C f of x doesn't exist. Therefore, f is discontinuous at all integral points. Conclusion you can write. F is discontinuous at all integral points. Discontinuous at all integral points. Like this you can define. When it is not integer, it is continuous. When it is integer, it is discontinuous. So this function is discontinuous at all integral points. So in this problem they are asking, show that the function defined by g of x, x minus step x is discontinuous at all integral points they are talking. They are discussing integral points. Directly straight away I can say, I can consider, let C be an integer. Let C be an integer. You can consider like previous problem what I have done that way only. Let C be an integer. So then because I want to prove that it is discontinuous at all integral points. Now limit x tends to C f of x. Limit x tends to again at C minus left limit. X tends to C minus. So not f of this is given g of x. So take g of x, right? Consider g of x. Now gx minus step x. So if you substitute the limit, it will come. This is a x polynomial at C minus step x value left of C. Left of C means step x will be, you will get C minus 1. It will come C minus C plus 1. You will get 1, right? Why? Because left of C step function will give C minus 1. Now limit x tends to C plus g of x. Limit x tends to C plus, here we will get C minus, step x will be C plus, it will be C only, C minus is 0. So I can write here limit x tends to C minus f of x, g of x not equal to limit x tends to C plus g of x. Left limit not equal to right limit, right? That means limit, here in this case I can write limit x tends to C, g of x doesn't exist. That means the function is discontinuous at all integral points. Therefore g of x is discontinuous at all integral points. Now the maximum possible questions I have explained are 4 marks. So like this, suppose if we get any new question, then similar to like this, the question will be there. If we thorough with these questions, whatever the question they will give, definitely you are able to answer. Try to solve all the questions properly, then be prepared to get maximum score. Thank you. See you in the next video.